Hello everyone, welcome back to section 1.4. I'll be going over cooling and heating. So we know from equation 3 of section 1.1, when we have a body immersed in a medium of constant temperature, the change in temperature of the body is represented by dt equals k times the quantity a minus t, where a is the temperature of the medium, t is the temperature of the body, and k is a positive constant. Now we'll just go into an example. Example 2, you remove a coal from a fire, find it is 320 degrees Fahrenheit, and leave it to cool in a cooler at 30 degrees Fahrenheit. After 1 hour, the coal is 180 degrees Fahrenheit. When will it be 90 degrees Fahrenheit? So right now is a good time to pause and work through the problem by yourself. Now I'll be going through it. So we're going to start by plugging in what we know into the base differential, and that is a equals 30. So dt is equal to k times the quantity 30 minus t. And then we're going to isolate the variables and get 1 over 30 minus t dt is equal to k dt. Then integrating both sides, we get that negative natural log of the absolute value of 30 minus t equals kt plus c. And then, by the definition of Newton's law of cooling, we know that it is now negative natural log of t minus 30 is equal to kt plus c. And so we can just take that negative and pull it into the natural log to get the natural log of 1 over t minus 30 equals kt plus c. Now, to get rid of that natural log, we're going to set both sides to the e. In this case, is going to simplify down to 1 over t minus 30 is equal to e to the c times e to the kt. Since e to the c is a constant, we can just set it equal to a variable. In this case, I chose d. So 1 over t minus 30 equals d times e to the kt. And now, solving for t, which is the temperature function, we find that t of t is 30 plus d to the negative 1 times e to the negative kt. So starting with our initial value, t equals 0, so t of 0 equals 30 plus d to the negative 1 times e to the negative k times 0 equals 320. We find that d to the negative 1 equals 290, and we can plug that back into t of t, which is t of t equals 30 plus 290 times e to the negative kt. Now using our another initial value, t equals 60, so t of 60 equals 30 plus 290 times e to the negative 60k equals 180. Solving for k, we get that 1 over 60 times natural log of 29 over 15. Plugging this back into t of t, we get that t of t is equal to 30 plus 290 times e to negative 1 over 60 times natural log of 29 over 15 times t. And to finish this off, we're going to set it equal to 90. Solving for t, we find that it's going to be approximately 143.39 minutes. And that's how long it's going to take for the coal to reach 90 degrees Fahrenheit. Thank you everyone for listening, and I'll pass it on to Michael.